Hey everybody, how are you? It's nice to see you. It's Tim here. We are going to be creating a multi-threaded command line utility. I thought that it would be fun to do this live on stream, and so I just kind of had like some time available. It's Saturday afternoon. It's actually surprisingly nice here in New Zealand. So if this is your first time ever watching a stream, please introduce yourself in the comments. If not, then I guess I'll just be talking to myself. If it's a recording, please hit subscribe or like or whatever you would prefer. Follow me on Twitter even, and we will be able to, and you'll be notified next time whenever I go live. Okay, cool. So this is being, hey Kyla, nice to see you. We don't have many people at the moment, but that's fine. This wasn't a scheduled stream. I just had some extra time, so I thought that I would hang out. Let's kind of get started. So what I thought that I would do was hello one. It's nice to see you. I've got a blank screen, which isn't awesome. So let's actually start with a little project. I want to create like a temperature monitor, which I will call, let's just, because it's relatively simple, it's relatively straightforward as to what we actually want. And like, I'm going to call it Tmon for temperature monitor. So it's just a little, and I don't actually have all of the code written because I'm actually trying to learn. Well, I've got the concurrency stuff. I've got a good pattern for it, but I want to be able to really see. I want to sort of work with everybody to kind of get this thing going, and I've got a good idea about what I want. So we want. And in fact, there's a really good crate which will enable me to ping the CPU. And I can't actually remember what it's called, which is awesome. Apologies for this. So let's try and find the right crate. And if we can't find the right crate, I might have to just fake it. Sysinfo is what I'm pretty sure that I wanted. There are two, and let's just work with sysinfo because that will do what I need. But there are two sort of slightly competing crates, and I'm just going to call in or bring in version. I could just bring in version star just to start with. And but it's actually version 029. Okay, that should be all that I need. Everything else hopefully will come from the standard library. So to start with, we will read the temperature. And to do that, I need to go into the sysinfo docs and figure out how to actually read the information. And when we start up, we actually need to create this thing called we need a refresh method, and which is essentially it starts up by creating a it starts up by creating a like a data structure, and we've got disk information, and what I want to do is temperature, but maybe we don't get temperature. Maybe I only maybe I only get, say, CPU usage, which is okay. We actually maybe load average. So I need, so a system and system extension, I need to bring that in, and I saw this comment, Pokemon powerful temperature monitor. I love it. I wonder if we can look at a really bad temperature, like a Pokemon reference. So we'll just start with this sort of simple example, and then we're going to increase the sophistication over time, hopefully fairly rapidly. And I don't even need read temp. Maybe we'll just convert that to read stats. So first thing that Cargo will do, Cargo is the package manager for Rust. It's going to suck down all the dependencies. I've already downloaded most of them. And immediately we get a typo. Aha! So now I've got some structured data. I've got my load average, 7.5, 5 minutes, 15 minutes. So my computer's under some stress. But what we actually, let's just say that's what we want. I will just do something a little bit sneaky, which is manually create JSON. Now this is dangerous because, well, yeah, why is it dangerous? Well, it turns out that JSON is a file format and I'm just cheating. We could use something like Surday, but I think for what I'm trying to achieve now, I don't require all of that sophistication because I have such structured data. I will probably be proven wrong. So now I actually should be, I'll no longer print out hello world. Yeah, I immediately am proven wrong by the fact that I've got all of this, you know what I should have done? Proven wrong by the fact that I have all of these syntax errors. But I can fix that. But I now have something that looks a little bit like JSON. And so now suddenly I have a utility which can output structured data. And that's kind of cool. So I've got some use. But what would be really nice would be to have a utility which could sit in the background and continually check, let's say once every minute, what the system was doing, and then go and what should it do? It go and check what the system was doing, but also be responsive to things like interrupts and potentially also send your data via a webhook to some other location. So what we want to do, and maybe even pull in more data sources. And so it's not just sitting on the main thread. We could instead create a couple of helper utilities. And to do that, we don't need to focus, like we don't need to use, let's say, shared memory. The whole point of this discussion is really to, by the way, this is very accurate. There is another way around this, which is actually a raw syntax. So like the thing here was like you should have just used a single quote to get around all of this escape characters. But Rust doesn't like single quotes for long strings. Single quotes denote single character values. But B, to get around it a little bit easier, Rust provides a rule syntax. Anyway, what I was saying about my concurrency stuff was that I do have a little bit of code here already whereby we want like a helper thread or a worker thread doing all of the like hard work, and our main thread sits there waiting for commands from maybe an end user, or maybe a configuration file would like to be updated. And so it's continually checking itself, but not actually doing any work itself, really. That didn't make any sense. So apologies for that. Let's start by saying that we've got our worker thing, and our thread is going to be here. We've got a method in the main thread that creates a new thread, then our worker, and we're going to throw all of this in here. Now we've got a problem. This is only going to run once. What we want it to do is to kind of run continually, and you could just say loop and thread sleep and sys time duration from seconds 1. Let's say for every second we get a new piece of output. And now inside the main thread, we can call join. Now, we don't get a lot of advantage from what I've recommended, which is like using channels right now, but this will come. And the other question you may have is like, why on earth would you bother doing this inside its own thread? Oh gosh. I need a semicolon, and I'm using a stud. Oh, so that's a stud thing. And by the way, if you've got any questions, please shout out, and I will be more than happy to correct myself because I probably made a mistake. Now I have my main thread pumping out the load average every second, and that's kind of cool. And notably, Command C actually works. And so I can interrupt the program as it's executing, or do anything that I might want on the main thread without it actually interrupting or like having to deal with the fact that I want to pause in between as I'm going. And so let's say that I wanted to I'll just see if I can exaggerate the problem by sleeping on the main thread and then trying to cancel. I probably am going to find myself very embarrassed that I don't need to. So I'm going to try, so I can cancel immediately. But, oh, for 1 second. So I'll just try and interrupt. Oh, it still does work. That's interesting. But essentially, the main thread is stuck. There's nothing else that it could do. Let's say that you wanted to send this utility some more information or update a config file. Then having the work in a separate thread is actually, you know, sort of helpful. I don't know if anyone has been in a position where they have been stung by that themselves. I want to now go into the sysinfo crate and kind of go back to checking whether or not I should, let's say that I'm receiving requests and I actually want to check different parts of, I want to sort of create a server that can we can respond to different requests of different types. And so I might be saying that my load average, and then, or I might be looking for something else. Let's try to find component. We want the temperature. Temperature was where we started. And the question that we wanted was what is the current temperature of the computer that we're running. Now, this is a little bit convoluted at the moment, but what I want to be able to do is have a long-running server just sitting in the background and somehow the ability to send it commands and for the utility to kind of keep accepting them and then changing what it wants. I have a problem, and that is I need to be able to send information into the into a channel. Sorry, into the thread that it's running. And I will say that I've got like I'm just going to change, I've got commands previously, but let's say that I've got the request and I have two sides, a transmission side where I send and a receiver side. And the main thread is the transmitter. It is the sender. And one of the things I would like to do is loop here and say, essentially have all of the command work in the main thread, and then the worker thread is just doing, is performing instructions that I would like. So essentially all of the business logic happens in the main thread, but and the worker is just doing what I want when I want it, which sounds maybe a bit rude, but hopefully not. The where do I go? So I want to I've got my transmission, and then I want to send a request and say load average, and then let's sleep for 5 seconds. And inside the worker thread, we no longer have to do any business logic. We don't have to, or essentially the business logic changes. We can go with we've got this interesting dynamic where we can iterate over the messages that come in through the channel. So when there are no messages, there's no work to do, and the thread will just wait. And now our loop has changed. And we all immediately have a problem. And that is, actually, let's just change our logic so that if we'll match on the request. The request is an instance of one of these request enums. if it's load average, then our job is to calculate the load average, and then I'll just return back our JSON string too, because it's somewhat simpler than starting something new. So the format macro will take our template string and return something that's actually valid JSON, but it turns out that we are sort of cheating slightly because we're not actually using a JSON library. Now, if we don't have if we don't actually know how to do temperature yet, and I'm just going to punt that out with a to-do macro. To-do will panic at runtime if it receives this request, but that's not going to happen because we're not actually accessing that yet. So we've now shifted our business logic from the worker thread into the main thread. So there's potentially a better... By the way, hi from New Zealand. It's really nice to see everybody. The worker thread has all of the work to do, but it doesn't actually have any of the specific what doesn't it have? It doesn't have any actual business logic. It doesn't have to make any decisions about what it does. It just responds to requests. Just a second, everyone. I am just being called. Just one moment. Sorry, everybody. Okay, I've just got a 3-year-old who's panicking slightly. And apparently the scones aren't being as easy to cook as they should be. I hope... Well, look, we actually didn't have too many people drop off, which is surprising. And surprising slash I kind of astonishing. So I had forgotten to pull in the channel type or the channel function itself, and now I've got a couple of extra things to do. Unused imports, we don't call the temperature yet, that's okay. And we have an unreachable statement. Oh, this will never actually happen because we are looping forever. And I'm just going to... what am I going to do? I'm going to wait until sometime in the future before fixing that. Although it's just a warning, and I've got a problem here on line 36 where I've got a request. I'm also going to change one thing as well, which is that I want to add a folder to workspace Tmon, and that way hopefully Rust Analyzer will be able to find my project inside the thing. Oh, okay, so what have we got? We got an error And the error is because we are trying to access a variable that from two places. And so this request underscore RX is the receiving side of a channel. Now, that's a problem for Rust because Rust doesn't want to have ownership in multiple places. So instead, we have to move ownership from the parent scope or from the main thread into the worker thread. But it only moves what it needs. So in our case, we only reference the variables from or only references one variable. So request TX is still available in the main thread. And now we have a slightly different problem is a slightly different word. That is, we no longer have any output. And kind of that's annoying. And that is because we actually have no way, this string doesn't go anywhere. So we generate a string and then it just immediately vanishes. So we actually need a second channel to go back into the into some place. So we could, for example, let's say, convert this to a message and then print it out. Inside our worker thread, but now we have kind of convoluted our concerns. I'm surprised that this is a problem because, it's a unit that it's received. Because I thought that we were sending back just a delightful semicolon, which is like one of Rust's favorite friends. And the second channel isn't typed. Rust can't infer it, so let's fix that. And now we can print things out again, but that isn't super satisfactory for us. What I am going to do is say that I'm going to actually create a different variable, which is my printer. Now, you may think this is completely overhead. This is complete overhead. And in many instances that you would be right. But the reason why I want to put printing to a standard out, printing to standard out into a separate thread is that the standard, like writing to a file, like writing to standard out actually does block. And so in moderately high performance applications, you will want to be able to ensure that the data that you're sending to standard out doesn't interfere with your ability to continue to receive commands. And again, I feel as though it's probable that people watching the stream or watching the recording are going to say, no way is this worthwhile. Like, just print it out here in line 34. And but it's more fun with more channels anyway. So we're going to start with the main thread. That's going to send requests to the worker, and then the worker is going to send the results into printer. Printer and the worker are going to both be controlled though from the main thread, which sounds a bit silly, but I hope that you will forgive me. Now, response TX is actually over here. So we start, we do our poll, we create our format, then we send a message, and then we print it out. And it turns out that our printer is getting a valid JSON object. And so what we might want to do is I love this. So, Rod Ead, who may be familiar from the Actix Web program, is monitoring, and it turns out that this is a known problem. That if you send a truckload of data through standard out, it will actually start interfering with your program's operation. And uh, and so again, whether or not this is justifiable in your own program is up to you. And hopefully, but I want to also say that it's not actually very difficult. Uh, Threads get a bad rap, but actually, that's because it takes tens of milliseconds to instantiate a thread. But once they are running, they take nearly no resources at all. And essentially, this is the entirety of the work that we need to do. As soon as we shut things down, as soon as this channel is closed, everything will be cleaned up really neatly for us. And but let's let's try this new approach. And naturally it breaks. So on line 42, I need a semicolon. I can fix that. What we want is my system average. And I'm actually surprised at how much work my computer is doing. I suppose transcoding video, sending it across the internet, as well as compiling, takes a little bit of work. You can see that actually 1 minute has gone up a lot. But I will, I'm wondering, like, is that me? Is that this program? Let's go and check the temperature. And how do we do that? Well, one of the cool things about traits is that these extension traits are implemented on this system object, although I'm going to actually double check the docs. I think I know what to do, but I really want to avoid embarrassing myself. So I'll go and check the docs. So we are going to go to this. Just bring up the right page on the other side. So we're back in crates.io, go into sysinfo, and what we want to find is the component API, and it says that it says components temperatures. Okay, so let's just print out, let's do things in quote the wrong way by going into our worker thread, and if we get temperature for component, I'm just going to print a standard error with error print line, just for no other reason than demonstrating that it could happen. Oh gosh. Interestingly, there's a thing. If I have no message, the type system the type system is convinced that it needs a message, like it needs a string here. And what about a request that comes in that doesn't actually have a message? We don't have anything yet. Actually, I may as well just send it through. I'll change my mind. We're just sending the components right through to I'm not going to do load average because we know what that looks like at the moment. But I do want to start checking the temperature of my computer. I expected a string, but I found nothing. There's another semicolon. That's nice. But he says this won't work. I actually need to I need to extend a string and then expand it. That's not happy. I expected a string, but I found unit. Oh, and then I need to go back here. Now, I know that some people is going to be screaming at the screen right now saying, no, what you need to do is you need to use an iterator on components and then collect components and then apply a map and then join. And you're right, but oh my goodness. But I thought that I would avoid some problem. Does not need to be mutable. You don't need to be mutable. Yes, you do. Okay, fine. I'll use the method. Sorry if I'm not explaining this. I'm just trying to get this thing to work. Okay, whoa, there's core temperatures. There is a lot of core temperatures. I am in NVMe, so you'll get to learn a lot about my internals. There's the temperature of my hard drive. How about I add a new line? So this computer has 6 physical hardware cores. They're all sitting at about 76 degrees. All right, just around 80. I got my Wi-Fi module as well as 57 degrees Celsius. And whatever PCH Comet Flake is, if you know who that is, I would be curious. This NVMe is probably NVIDIA something, so I presume my GPU. But there's a whole bunch of temperature information, and then it's a bit confusing because we now need to make a decision, which is, well, how on earth do we deal with this? Because I thought there was just a temperature, but it turns out that there are multiple temperature sensors, and every computer that implements this. Ah. Yeah, I just made people scream at me. Sorry. Yeah, we need to append. We're not. That's all we needed to do there. I'm sorry for I'm sorry if that really frustrated you. I oh gosh. The and then I made this other mistake, which is like, why are you calling the wrong method? And let's so I apologize about that. I am going to get back to it. So let's look at the. I'm actually going slightly off track because what I'm trying to do now is looking up the sysinfo documentation and not talking a little bit about channels. So we've actually almost implemented our multi-threaded server. What we don't have is, actually, I know exactly. What we don't have yet is the ability to do this dynamically and receive requests. And I'm curious as to whether or not anyone has any thoughts on this. We could listen to a socket, but that's a decision that we will, we'll think about later. And let's just, because I did say that I wanted to create a temperature sensor thing, so let's do that. Oh, by the way, the maintainer of this package that I'm relying on for the demo is on Patreon and GitHub sponsors, and I would encourage you to sponsor them if you have the ability to do so, this is the really important crate, and hopefully it can provide, if it provides you some utility, then I encourage you to kind of shout out. So the thing that I wanted to do is get some structured data out of this components. So I need to go into the docs and structs component, the temperature of, so every component, and so this would be a physical hardware component, has its own temperature. So this is a bit of a problem because we want to be able to, say, join our CPUs together. I was hopeful to kind of create an array of CPU. So our temperature is component temperature, but we actually can't identify the components without inspecting whether or not we can check the label that we just had. So we had core temp. And so if, well, what I'll just do to start with is say what I'm interested in is the temperature of my CPUs. And if the component is component label starts with core temp, I assume that there's now a core temperature. Or at least it's the temperature of a CPU core. But I'm going to just see if that's sufficient. It starts underscore with. Okay, cool. So we've formatted them down. Now I don't know what a package is. So how about, so it looks like this core temperature, it looks like these are all simply I want to know if sorry, I'm not making any sense. I apologize for that. So what I want to be able to do is just extract the CPU core temperature and do this into an array. And temp push core temps. And from here, temperature info can just become the debug version. It turns out that if you have a vector of a vector of floating point, the debug representation is valid JSON. So I can kind of sneak my way around having to do that properly. Oh, goodness me. So there are all of my CPUs. And we now have structured data at a particular time point, which is kind of cool. And we are running them across multiple, so I am running things across multiple threads, and that is sort of where we are at. I wonder whether or not if anyone has any questions. Otherwise, I've just hit 45 minutes, and so I want to again encourage you to like and subscribe and do that thing. Hit the follow button if you would prefer. I'm also available really actively on Twitter/X or Mastodon and a bunch of other channels too. And if you would like a link to my Discord server, because you've survived in the stream for so long, feel free to send me a note and I will get you an invite. It's a slightly more exclusive club than a lot of Discord servers, so I tend not to. Oh, actually, no, that's not quite true. There is a public link. It's on my YouTube channel. If you go to the actual channel page itself, there is a Discord link there. Okay, well, I will wrap up. I hope you've had a really lovely stream, and I will say goodbye. Take care. Thanks so much. Bye.